introduce this, I like to think about a real world scenario and show how this is actually happening. And maybe it'll give you a better understanding of what composite functions are, because I think people don't get a good grasp of what they are, and it just gets confusing from there on. So let's say you and two of your friends are splitting the cost of renting a car for a trip. So you're going, let's do like a weekend trip or something like that. I was doing 4 days, so I guess a long weekend trip. And you're gonna rent a car. And the car rental place, what they do is they charge you $32 per day, and then a flat rental fee of $25. So they're gonna charge you that $25 regardless of how many days you do the rental for. But in addition to that, they're also gonna charge you $32 per day. During the trip, you and your friends find $50. So like, I don't know, you go to some place and there's $50 on the parking lot, you pick it up and you're like, oh, we're gonna use this towards the car rental. So that was the biggest expense of our trip was the car rental. So we're gonna apply that $50 to that. And then we're gonna split the remaining. And so we want to be able to figure out how much will each of you need to pay for a 4-day trip. So if you were working this problem, or if I was working this problem, and I wasn't thinking about composite functions or anything, how would you figure out how much you would all need to pay? All right, well, I mean, what kind of equation are you talking about? All right. And what's that telling us? Yeah, I mean, you're right. It's basically the cost, right? That's the cost of the rental car. It's gonna be 32x plus 25, but what's x in our case? Is 4. So we're basically gonna do 32 times 4 plus 25. That's gonna give us our cost of a rental car in full, which is gonna be what? 32 times 4 plus 25, 153. So that's the cost of our rental car. There we go. Any questions on that? So even if you didn't set up the equation, or I guess it would be a function really, but even if you didn't set up that function and you just did 32 times 4, because it's $32 per day for 4 days, plus the $25 flat fee, that'll still give you your cost of $153. Now, are we going to take that 153 and just divide it by 4 to figure out how much each person needs to pay? We want to subtract the 50, right? Because we found the $50, we're going to apply that to that amount there. So we're going to take our $153. We're going to subtract the $50 we found, and that's going to tell us how much we're going to have to pay. So that's going to be, I think I can do that in my head, $103. So then, to figure out how much each person would pay, we're going to take that 103. We're going to do what? Divided by how many people? Oh, it was 3 people. Yeah. I thought it was 4 people for some reason. It's you and 2 friends, so it's 3 people. So we're going to divide that by 3, which is not going to work out well. So it's about $34.33. Somebody would have to pay a penny more. Any questions on finding that? So we did a whole process, and I like that we found the function because I was going to introduce that later, but we already got that going. What if you wanted to calculate it for 5 days? We'd have to start all over again, right? Put a 5 in, subtract the 50, divide by 3. What we want to do for 6 days? We change it to 6. We multiply, we add, we subtract, and then we divide by 3. What if we want to make it quick so that way we could just plug the number in easily and not have to do all these steps. We can combine all these operations we're doing into just one function, right? Because we know what we're doing is we're doing the 32 times how many days plus the 25. Then we're subtracting 50. And then in the end, we're dividing by 3. So we can create this by looking at these as separate functions. So for the cost, we said it was, whoa. We said it was 32x plus 25. But then we subtracted 50 from it, right? So our cost function is actually going to be 32x minus 25, right? Because we are applying that $50 that we found to the cost of our. And then the split, how much the cost is, we're taking whatever the cost is and we're dividing it by 3, right? That's what we're doing. Any questions on that? If I wanted to combine those together, what will I do? We're taking whatever the result of this one is, right? And we're putting it right here. There you go. So if we want to combine those together, we would say, well, it's going to be 32x minus 25 over 3. And so now we can just plug in whatever days we want into that function right there, and it will tell us how much each of us needs to pay. Any questions on that? What we found here is the composite functions of the cost and the split functions we did there. So if we wanted to call the cost function C and the split function S, what we just found would be S of C, which we'll talk about that a little bit later, what that naming convention is. Any questions on that? So that's what we're going to be doing. And so we're going to be talking about composite functions, forming a composite function. So given two functions, f and g, the composite function denoted by, and they use a little open circle between the two, and that's read as f composed with g. I'll say f of g a lot, which I don't like saying, and which you probably heard before. Has anybody heard of someone saying that's like fog? Ever heard that? Yeah, I don't really like saying fog because when you start changing the names up, like if you do that, that's Gog, that's golf, and then if we did f of f, it'd be fof. That's really hard to say. Fog is fine, but when you start doing other ones, it just starts sounding really bad. So that's why I'll say f of g, g of g, f of f. But if you want to be really proper, the way to say is f composed with g. G composed with G. That's the actual proper technical way of saying it. But what's really important from this is this right here. F composed with G of X is the same thing as F of G of X. And what that means is that you're going to take the function F, and everywhere there is an X in the function f, you're going to put g of x there. And we're going to do some examples of those later on. Yeah. Another important part is this right here. The domain of f of g, or f composed with g, is the set of all numbers in the domain of G, such that G of X is in the domain of F. So it's going to be the domain of G, such that g of x is in the domain of f. So when we go over some problems, I'll talk more about what that means. But what it means is, in simpler terms, is that you need to be able to put that value into G, and then whatever the output from G is needs to be in the domain of F. Because what it's going to do is you're going to do G of X and then F of that value. And here's a little picture that kind of shows it. I still debate myself every time I use this picture, but I like it, and then I start explaining it, I don't like it. So basically, you have the domain of G here. The domain of F composed with G is going to be the subset of that, such that it's in the domain of G, but the output, once G is applied to it, is in the domain of F. Okay, so the output of G needs to be in the domain of F here. That's that overlap here. And so that way it can continue the mapping through F. Any questions on that? Because these items out here are not the domain of F, so I can't continue my next hop. So it's going to be a subset that gets mapped from G, and then it can get mapped from F to the F of G of X. And there's another little one here. You have your input. And remember we talked about functions being just little factories that take input, take output. Well, you put the input in the G, you get G of X. That's the output of my function G. That goes into F, and then that output is F of G of X. So you can think of composite functions as like a two-step process. You apply the inner function, then you take that output and apply the outer function, like what we did with the car rental thing, right? We figured out the cost, and then we split it. Or you can think of it as one big function that just takes the input and gets the output, which is what we did when we put our two functions together, when we composed our functions together. All right. So let's look at this problem right here. So I like these, but people always struggle with them on the homework. So I was like, well, let's do one in class. So what this problem is that they give you X values. So these are our inputs. When you put a -3 into the function F, the result, the output is -8. When you input a -2 into F, the output is -5. When you put in a -1 into F, the output is -2, so on and so forth. When you put a 1 in the G, the output is 0. Okay? Any questions on that? Trying to pay attention there. No. So for part A, they want us to find F of G of 1. And I know my composed symbol is horrible, so I'm going to try to fix it. And my G's always look like Y's. Let's try this. So whenever I'm working these, what I recommend to people, first thing to do is rewrite it. And what I mean by that is, remember the definition said that if it's F composed with G of 1, that's the same thing as F of G of 1. Any questions on that? So if I ask you what's the inner function here, for this composition. What would you tell me is the inner function? What do y'all think? But just the function, but that's like what you would be, the operation you'd be doing. But G is my inner function, right? G is the function on the inside. So if we're going to evaluate this, the first thing we're going to do is G of 1. What's the outer function? F, right? So we're going to apply F after. So the first thing I want to do is find out what is G of 1. How do we figure out what G of 1 is? Anybody know? What's that? So we go to the chart, X is 1, we're putting that in the G. That's going to be that point right there, that value right there, right? So G of 1 is 0. Any questions on that? All right, so if we want to figure out what's F composed with G of 1, what are we going to do now? What do y'all think? Not F of 1, we're going to do F of 0 because G of 1, we figured out, is 0. All we did was take what G of 1 is and substitute it in there. The output of G of 1. We're going to put that into F now. And so, let me erase all my scribblings up here. And so we put a 0 into F. What do we get out? -1. So this is going to be -1. Any questions on that? B. Let's go with red. And so B, we're trying to do F of G of -1. That means we're going to do F of G -1. So what are we going to need to find first? G of -1. Good. So G of -1 is what? -1 and the G, I get 0. Yep. Was it? No? Okay. Just so happens that they're the same. And so we're going to do F of what now? 0. And we already know that that's going to be -1. Any questions on that one? Let's do one more and then I'll let y'all try the rest on your own. Let's do it up here so we can see them all. So C is what? G of F of -1. G composed with F of -1. So how are we going to write that one? Is what?
It's the same way like with the G on the outside.
Yes. Yeah. So it's going to be G of F of -1. My negative is really bad, but yeah. I'm going to fix it. It's going to annoy me. There we go. So what are we going to do first? We're going to find F of -1, always the inner function first. So that's going to be -1 into F, which results in -2. So now we're going to do what? G of -2. Good. And that is going to be what? -2 in the G results in a +2. Any questions on that? Nope. All right, so try the other three, D, E, and F by yourself, and then we'll go over them. Anybody can't see it up there? 'Cause I zoomed out so you can see the work window. Just let me know if you can't see them. And I don't know. How long do you think you need? So you got 5 minutes? Anybody still working on it? No? Anybody still working on it here? Doesn't look like it. All right. I'm going to erase these other ones. So we have room. You're good? Okay. I guess I could have just, oh well. We've already started now. I could have just copied it and put it on another page. All right. So start with delta. We got G composed with F of 0. So first thing, we'll rewrite it as G of F of 0. So the first thing we need to find is F of 0, which I'll get for that. -1, yep. And so now we're going to do G, -1, which is going to be 0. Good. Any questions on that one? All good. All right. E. We're doing GOLG of -2, so we're doing G composed with G of -2. There's actually a company called GOLG. So that means we're going to do G of g of negative 2. Now, don't be confused that you're using the same function twice. That's fine. First thing we're going to do, just find g of negative 2, which is what? Put in the g, yep, positive 2. And so now we're going to do what? G of positive 2, which is going to yield 2 again. So it's going to be 2. Not always going to be the same number. It's just the way that our function ended up. G is a weird function. I don't know. Any questions on that? And the last one, f, which appropriately we're doing f composed with f of negative 1, or f of negative 1. And so the first thing we're going to find, well, let's rewrite it first. F of f negative 1. So we do f of negative 1. Oh, sorry about that. First, which is going to give us 0, nope, negative 2. And so now we're going to do f of negative 2, which is going to give us negative 5. Any questions on any of those? No? Got it? So that's how you use it if you have a table that just has the input and outputs. There's like a few problems like that in the homework. I think it does well to kind of show you like this is how you need to do it, to just step through the inner function first, find the output of that, and then put that into the outer function. Now, sometimes they'll just give us the function. They won't just give us the inputs and the outputs. Okay, sorry about that. I didn't recognize my finger for a while and then it took off. And so in that case, there's actually a couple ways. If you just, we'll stick to the same method we did before and we'll talk about another method. So if we have that f of x is 2x squared minus 3, and g of x is equal to 4x, and we want to find f opposed with g of 1. That means that we are looking for f of g of 1. So what are we going to do first? We're going to plug 1 into g. We're going to find g of 1, which is going to be what? 4 times 1, which is 4. Then what are we going to do? We're going to find f of 4, which is going to be 2 times 4 squared minus 3, which is what? 2 times 16 minus 3, 32 minus 3, which is 29. So if we're given the function, we just plug in the value into the first one, the inner function, get the output, plug that into the outer function. Cool. Any questions on that? Let's skip and let's do C. So we're trying to find f composed with f negative 2. So remember that's the same thing as f of negative 2. So what do we need to find first? F of negative 2. Which is going to be what? 2 times negative 2 squared minus 3. Which would be 2 times 4 minus 3. 8 minus 3. Which is 5. And so now we're going to do f of 5. which is going to be 2 times 5 squared. 3. Pay no attention to the wrong number I wrote there. There we go. Which would be 50 minus 3. It's 47. Any questions on that? No, we're all good. Now, in this problem, every time we're doing one, they're changing the function, the composite function we're doing. Part A is F composed with G, part B is G composed with F, C is F composed with F, and D is G composed with G. But what if we had to do F composed with G a bunch of times? Instead of plugging into G and then plugging output in, back into F, or I don't want to say back in, but plugging the output back, that's it again, plugging the output into F, we could find what that function actually is. What is that composite function? All right. So if we take these functions here, I'm going to rewrite them actually. I'm just bringing this down so I can look at it. And we say f of x is equal to 2x squared minus 3, and g of x is equal to 4x. And we'll move the cursor up the way. But if you want to find what is f composed with g of x, remember that is the same thing as f of g of x. Right? Any questions on getting to that point? So that means everywhere there is an x in my outer function f, I'm going to replace it with the inner function g of x. That means, should have that blank. I'm going to take my function f. It was 2x squared minus 3, right? But where the x was, I'm going to put g of x. Any questions on that? What is g of x? It's 4x. So let's write it that way. So it's going to be 2 times 4x squared minus 3. Any questions on that? I'm just trying to stop and make sure nobody's lost as we go along. If you get lost on one step, kind of game over unless you catch it back up. All right, and we can evaluate that, right? What could that evaluate to? Anybody know? It's not easy, so if you don't know, it's not a big deal. But we can actually square the 4x, right? It's like 4x times 4x, which would be what? 16x squared. So we got 2 times 16x squared minus 3. And I'm getting rid of the color because we've kind of combined our functions together at this point. And then we can do the 2 times the 16, which is going to be 32x squared minus 3. That is the composite function, f composed with g of x. I think, what did we find earlier? F of g of 1. I plug in a 1 right there. We get 32 times 1 squared minus 3. Would be 32 minus 3, which is 29. It's the same answer we got earlier. So there are actually two ways to do this. Which way you use, in my mind, it depends what you're doing. If you're going to use f composed with g a bunch of times, it's probably easier to find the function and then just plug in the value. If you're doing different composite functions each time, no, just plug it into the inner function, take that output, plug it into the outer function, and go that way. There's no need to do all this. Any questions on that? I got 10 minutes. So let's try. Let's actually use this one. Why not? Since we already started it. Only recognize it the second time I do it. So it was with f of x. So remember, that's the same thing as, oh, that's the wrong color. G of f of x. And so that means we're going to take g of x, and everywhere there's an x, we're going to put f of x. So we're going to have 4 times f of x, which is going to end up being 4 times, and notice I grouped this in parentheses now, because it's 4 times this whole function. It's going to be 4, oops, I used the wrong color in the parentheses. But there we go. And so now that 4 is going to distribute, and this would end up being 8x squared minus 12. And that would be your composite function. Any questions on that? For g composed with g of x, can't really do much with the color there because it's going to be all the same, but we're doing g of x. And so it's going to be 4 times g of x. Which I haven't been putting those outer parentheses, so let's get rid of them. And let's hit the scroll bar by accident. There we go. And so we're going to replace g of x with what it actually is. So it's going to be 4 times 4x. And that's going to end up being 16x.